Oh, we have our chem test today.
All right, plenty of time to get settled. Here we go. We always rotate counterclockwise for positive angles. Why? The sun. Quadrants. Yes, literally. Quadrant 1, 2, 3, 4. Okay? The sun. Okay? Everything that we have that's circular, from coordinates to the clock, all is based off of original sundials and rotational motion. So, like, that's why our degree minute second system is set up in terms of navigation, because everyone knew a clock. So, if I have a coordinate on a regular old coordinate plane, XY, what we get to do now is give it a whole new set of notation that's not actually XY. Now you'll do this part next time in trig, but now it's going to be radians radius. When you go on to trig, most of you next semester, radians radius, those are called polar coordinates, where instead of XY, now I can just say the length of the radius, how far away from the origin is it, and then its rotation. Makes sense? Like over here, I could say it's that much rotation and then this length instead of horizontal vertical. Okay? So to start that, you got to first get the proofs for it, which is where we lay the foundation. No, you don't have to prove anything. Not yet. Nope. Yet. Every coordinate, if you form a triangle with the x-axis, creates these triangles where you can use all your right triangle trig stuff on them. See, if this coordinate xy, well, here's x, here's y, it's going to be perpendicular because vertical and horizontal are perpendicular. The hypotenuse, this is one thing I do want you to put on there, is going to be my radius, and it is always positive because it's the distance from the origin. Distance can't be negative. The legs are allowed to be negative because that's the, that's the coordinate plane. You can have positive and negative numbers. But the hypotenuse is always going to be positive number radius. Another way to think of it is if I do Pythagorean right now, if I said radius squared is x squared plus y squared, right? That's how I'll get my radius. Oops. Well, if I square this and I square this, aren't those going to be positive numbers no matter what? So when I do the square root of, it's a square root of a positive number, so I know it's not going to be imaginary. Technically, you would say it's plus or minus, but I can't have a negative distance. Okay, so radius will always be a positive number. What this also allows me to do is set up a whole bunch of coordinate shortcut cheaters and say, if I've got a triangle like meow with my horizontal distance, my vertical distance, and my radius, we'll now start saying all the stuff. What's sine? Opposite over hypotenuse, right? So I'll say it's y over r. Cosine. X over r, adjacent over hypotenuse. You no need to write it. It's right next to this. All of these coordinate shortcuts right there. Which means if someone gives me a shortcut, all you got to do is find R. You got all 6 of your trig ratios. You technically don't even need to draw the triangle or do anything with it, because you know that opposite is always Y, adjacent is always X, hypotenuse is always R. That's just how the triangle is formed. Maybe one note to put to yourself, just so you don't do the dumb. It's always a triangle made with the x-axis. Don't make the triangle with the y-axis. Okay? Form your triangle with the x-axis. All right. Another thing. Wait. Yeah, we'll come back to the quadrantal angles. So, I give you a coordinate. 8, -6. What quadrant is that in? 4? Because I'm going to go 8 that way, 6 that way. So technically what's really happening is I'm rotating around like this to get my point. My whole triangle is just, no, imaginary? Not imaginary. It is a construct of my creation. There we go. But construct and creation are synonymous. I've been up since 4. Just letting you know. Because Butte County Electric decided to do some rolling blackouts to update their grid. And when they do, all of our baby monitors start beeping because there's no power anymore. And they're running off a battery. And then the beeping woke up the child who crapped himself. So we've been up since 4. I'm tired, you got to deal with it. If I have a coordinate 8, -6, that means my sides are 8 and -6 respectively. Get some Pythagorean on there. What's my hypotenuse? Or recognize the 3, 4, 5 triangle. 10. Because -6 squared is 36, right? So I can still do Pythagorean with negative things. That's why all of this works on the coordinate plane. And then once I have that, you can find all your ratios, right? Sine. Okay, so first of all, this is theta. We call this theta prime. It's a reference angle. We'll get to that in a minute. But right now, the sine, cosine, tangent, all that of theta is the same as theta prime. So, y'all good. Sine. Opposite over hypotenuse. -6 over 10, reduce it. Cosine. Adjacent over hypotenuse, reduce it. Tangent. Opposite over adjacent, -3/4, reduced. And then cosecant, reciprocal, secant, reciprocal, and cotangent. But they're just saying, I don't need to draw the triangle for that. Okay. Y'all cool if I erase the triangle? What they're saying is, I was given an x and a y. If I do Pythagorean with x and y, 8 squared plus -6 squared, 64 and 36, add them together 100, square root of that. My r is going to be 10. I now have x, y, and r. So shove 8, -6, and 10 in those. You don't have to draw the triangle. Now you can. It took us, what, like 3 seconds to draw the triangle if you know what quadrant you're in. So it's not a big deal, but I don't have to draw the triangle. I can just plug X, Y, and R in their appropriate spots. Give it a whirl. Make sure that you rationalize where possible. Actually, this is just a 3, 4, 5 triangle. Let's do 1B. Like, no joke, 1A is all of that except positive. It's the exact same thing but positive because it's quadrant 1. So let's do 1B. Don't assume just because there's a 1 and a 2 there that the other one is square root of 3. 1 square root of 3, 2 happens when 2 is the radius, the hypotenuse. -2 is your adjacent this time. So you know X, you know Y, find R, plug them into the cheaters. The power of Christ compels you. Okay, you've got those cheaters. If you have these coordinate cheaters, here's X, here's Y. -2 squared is 4. -1 squared is 1. Put them together, 5. Square root of 5 is my radius. And then just jam X, Y, and R into shortcuts, making sure you reduce wherever possible. So for example, -2 over square root of 5, -2 root of 5 over 5. -1 over square root of 5 is negative root of 5 over 5, because I have to rationalize it. Why is what negative?
I think it's the other way around. It's the other way around. Yeah. Cosine and sine. Yeah. The first one should be negative.
Oh, I put X in Y spot. There we go. That's better. And then Y over X. And then floppity flop all of them. So negative root of 5, negative root of 5 over 2, and 2. I still owe you one for yesterday, didn't I?
Hey, I haven't done anything today.
Maybe that's the problem.
I'm being good. I'm not on Sam's side.
Yeah.
So, are y'all okay? Like, shortcuts?
Yeah.
You can draw the triangle. What quadrant is that in? 3, negative, negative, right? So, -2, -1, square root of 5, jam theta in there, go to town, right? It's just, if you don't want to draw the triangle, you got shortcuts. Okay? Either one's cool. I don't care which way you do it. Okay. These are all about one of the most entertaining words of the chapter, quadrantal angles. Just sounds fun to say. Makes you sound smart. Quadrantal angles. Well, what word do you hear in there? Quadrant. They're the angles at the quadrant markers. They're the positive and negative x and y axes. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are your quadrantal angles. Get used to saying everything in radians. Okay? You don't use degrees for a while in this chapter. Not until section 4.8 do we get back to degrees, I think. Okay? So, quadrantal angles are just those. Now, take a look at their coordinates. Why are they using r? Why aren't they using x and y?
That's the radius of the circle.
Right? Like, whatever your rotation is, your x or y coordinate, your non-zero x or y coordinate, is going to be the radius. So just use r. Either positive or negative because the coordinate plane still exists. Okay? So for those, when I have my exact values, I got to be careful about what's what here. Because do you notice on next to those shortcuts, they said a certain something? Cannot equal 0. Because, first commandment of domain, thou shalt not divide by 0. So we need to be careful with these. It is possible that our trig functions might end up having a value of you can't do that. Okay? So, sine of negative 180. At what quadrant marker is that? There. Right? There. Okay. Here. Negative 180. Well, is it the marker for quadrant 1, quadrant 2, quadrant 3, or quadrant 4? It's where quadrant 3 begins. But if I say negative 180, does that change it? Right? Because it's still there. Negative 180. What? Right, it's the same spot. They're coterminal angles. Well, if I'm right there, I have a coordinate of negative r, 0. And sine, last time I checked, sine was y over r. Well, y is 0. It doesn't matter what my radius is, because 0 divided by that radius is going to be 0. Okay? So these are all going to have special values of basically 1, negative 1, 0, or possibly undefined. Yes?
Would it be negative since it's negative r and 0?
Well, 0 divided by a negative r is still... Okay, no. Here. That's a point of clarification. I like that. The coordinate right here is at negative r0. Yes, the x part is negative r. But r is always positive r. So when I'm specifically talking about r in my shortcuts, it's positive r. Now, it wasn't going to affect it anyway because it's 0 divided by thing. But that is a distinction. I like it. That's a good question. Okay. Tangent 3 pi over 2. Where are we at? North, east, south, or west?
They're in quadrant
South. Right? The beginning, the divider between 3 and 4. So if I'm looking at, what's the coordinate? 0, and then because it was downward, negative r, and then r is just r. What is tangent? Ratio. Opposite over adjacent, y over x. Well, if I do y over x, undefined. The tangent of 3 pi over 2 is undefined. Wait till you see the graph for it. Okay. Infinite asymptotes. It means infinite asymptotes.
I think I'd drop out at that point. I feel like we're gonna have to do something.
Monday.
Monday? Alright, guys.
It's not hard. It's not hard. And then the quiz is Tuesday, yes. So can't do that. Secant of 4 pi. Well, first of all, where is 4 pi? Northeast, south, or west? I feel like if it's in the quadrant, we should say the quadrant. If it's on the quadrantal angles, use the cardinal directions. West. Are you sure? Oh, sweet Jesus, we don't know our directions.
Never eat.
Never expose. Oh, wait, no. This is school. Okay.
Never eat soggy waffles. Yeah, that's what I learned.
Never exposed who?
Never mind. No. It's right there. Okay. So them. So what is that coordinate right there? How about R0? Okay. And secant. What is secant for coordinate rule? R over what? Okay. So if I say R, which is just R, over X, which is, wait, R, then 1. The secant of 4 pi is 1.
Isn't 4 pi just 2
2 circles, yeah. It's still at that location, right? Coterminal angles. Two A, 2B, 2C. Get them.
Is this how we find the things in the unit circle?
We're headed there. You look at the title of the lesson.
Wait, so is X R?
Depends where you're at. On C, yes.
Oh, never mind. Okay.
Well, because if you look, 270 is quadrant 4.
Random reminder, if you don't need your notebooks for next hour, leave them here so I can go through them. Maroon 2, planning. And I did not go through them last time, so you have 2 weeks of stuff that I need to throw in. So please, if you do not need your notebooks, leave them here at this end of this class. You can pick them up at lunch. Okay.
I'm gonna come here for Spartan time anyway, so.
I think a good chunk of you are going to be here in Spartan time after you're released.
Yeah, I'm sure. Anybody that finished the test?
Because out of 19 kids, only 2 finished. So,
So we're all
You look at
Hmm?
the test. I'm not grading this yet, but this kid has.
What is the R's axis is 0 over?
no, I didn't look at them. No, my timing was off. I did not have the opportunity to speed run it beforehand. It was longer than I wanted it.
It's also.
Yeah, but what's this? Is that R? But you also have to use
Normally, if a test takes me more than 5 minutes, I scrap it and start over. Because it's times 6 for pre-calc, times 8 for algebra 2, times 10 for algebra 1. So if it takes me 5 minutes, that's a 30-minute quiz for you. That means almost, if not everyone, is done at 30 minutes. That one took me 3:29 or 5:29. Normally it's like in the 3:30 to 4:30 range.
Dang, now it's only like 5 questions.
I never.
I'm the teacher. It's supposed to be that way.
Happens if you never.
I don't think so. I just think it's smart.
Negative 90. Where you at?
All of it.
No, on these. Which one?
No.
Negative 90. Okay. So that's your coordinate.
Because it's on that page.
I was looking at this one. I didn't know you weren't done with 2B. So then look at the cotangent cheater.
You said yesterday, I think.
Okay.
Okay. Seniors 205, juniors 215, sophomores I don't remember, freshmen never. So.
No one cares.
So, first of all, identify which quadrantal angle each of them is. South, north, south. Okay. So if I go to cosine of 270, which has a coordinate of 0, negative r, which has a coordinate of 0, r, which has a coordinate of 0, negative r, you just jam those into the coordinate shortcuts. And you say cosine is x over r. Well, 0 over r is just 0. Cosecant is r over y. R over r is 1. Cotangent is not y over x, x over y. X over y is 0 over negative r is 0. Ta-da! Use those coordinate shortcuts. Okay? It's either that or you just do a quick sketch. All right? Is this okay, or are we just going cross-eyed? Okay. It's almost like we do well when we have notes and we're supported, right? Like if you can just look at the thing, oh, that's easy. Feel sorry for the freshmen who aren't doing diddly in algebra half right now when I give them everything and then they transfer to a different teacher for second semester. And now you don't get any notes and he takes away your calculator. Eat it, freshmen. Yeah, because it's algebra half and some teachers are adamant about arithmetic skills, as opposed to the standards we're supposed to be teaching, they take away the calculators.
I'm just glad it's 7th grade.
So, reference angles. Remember when I said always make your angle with the x-axis or your triangle? In quadrant 1, the reference angle is whatever the angle is. Basically, if you want to put up next to it, your reference angle is always positive. Okay? Reference angles are always from 0 to 90, or 0 to pi over 2, depending if you're in degrees or radians. Okay? It's always from 0 to 90, 0 to pi over 2. It's always, because of that, positive. And it's always formed with the x-axis. So in quadrant 1, if I say 60 degrees, pi over 3, then its reference angle is 60 degrees, or pi over 3. It is its own reference angle. It's kind of like when you're finally 18 and you get to start checking that box that says self instead of having guardian sign on there. Okay? Teenagers love that. Senior year when you finally get to like check that. I am the captain now. Okay? If I'm over in quadrant 2 though, my angle is theta. Theta was 3 pi over 4. I am just ballparking that. Okay? It looks like it's at 3 pi over 4. So its reference angle is formed with the x-axis. It's a positive angle formed with the x-axis. So if 3 pi over 4 gets you here, this is what? Pi over 4. So my reference angle is pi over 4. I want you to think about that word, reference angle. Y'all been through English. What are your references? Okay. Where are you getting your information, right? So when I say my reference angles, it means I don't need to know everything for quadrants 2, 3, and 4. I'm just going to look at its reference in quadrant 1. Because it turns out that everything on the circle is just those same 3 angles over and over and over. Okay. If you want to know it down here, there you go. If you're in quadrant 2, take 180 or pi minus the angle. That's your reference angle. How far away from the x-axis is it? Likewise, if I'm in quadrant 3, if I say that looks like it's about 5 pi over 4, I form my triangle with the x-axis. So my reference angle is again pi over 4 because I'm that far past the x-axis. Take the angle minus 180 or the angle minus pi. You're just seeing how far away from the x-axis are you. And then if you're over in quadrant 4, same deal. 360 minus the angle. If that looks like it's at 5 pi over 3, then its reference angle is pi over 3 because that's how far away from the x-axis I am. So positive angle between 0 and 90 between pi over 2 and 0 and blah, blah, blah. Here's a bunch of stuff for my coordinate shortcuts. Okay? So, sketch the angle, find its reference angle. 300. What quadrant we in? Quadrant 4. Okay. If I'm in quadrant 4, you take 360 minus the angle. That means my actual angle, theta, was 300. My reference angle, theta prime, is 60. That's it. Because that's going to be the angle that forms with the x-axis.
I think you should make that just
No!
Yes. I agree.
Where's negative 2 pi over 3?
Negative 2 pi over 3 would be the north.
Quadrant 1, 2, or 3, or 4.
Oh, you mean 2.
Negative 2 pi over 3.
2.
It is in 3.
Oh, negative.
Remember, here's pi. So go 1, 2 thirds of the way to pi with a negative rotation. Okay, so if that's regular theta, then form your angle with the x-axis. What's my reference angle? Pi is an entire semicircle. Pi over 3, right? If I went 2/3 of the way to the axis, then 1/3 of it is left.
I was definitely thinking 3 pi over 2, not 2 pi.
Oh, gotcha. That's it. Can you sketch the angle? Can you tell me the reference angle? If you ever say a reference angle that is larger than pi over 2, you're wrong. Reference angles are between 0 and pi over 2. Reference angles are always positive. Don't say a negative pi over 3. Okay? It's just, if I made a triangle in that position, that's where it would be. That would be its measure. Well, I suppose technically, no. Can I just do that and say that's 300, so this is 60? Yeah. Can I say like this? If you want to do that, go for it. But as soon as you start losing the sides of the triangle, people start getting a little weirded out in terms of the side values and the trig ratios. That's why I always make the triangle, but technically you don't have to. All three. Find me some reference angles. Ask yourself, what quadrant am I in? Remember, the radian ones, kids tend to have trouble with. No. Remember, pi is at 180. Quadrant 3.
That's what I'm saying. Radians are way easier.
If you understand fractions and you can wrap your head around 1 pi is at 180, not a full circle.
You know, I figure out where 240 would be.
Yes.
Because you can go 1, 2, 3,
Yep.
5.
I always count pieces like that. Yeah.
Okay.
Or is it like
So when you're looking at this 5 pi over 4, instead of thinking about cutting up the pizza, maybe cut up the calzone. Semicircle. Calzones are awesome.
have you been to the new place in Rapids?
To who what?
Have you been to the new place in Rapids? It's called
I've been to Rapid exactly twice in the last 8 months.
What's been twice in the last month? I go every night. Oh wait, no. I was in Rapid twice in the last week. I go every night.
Twice in the last 8 months.
Yeah.
Both times were just to pick up materials for a project. Later. My wife wanted a sunshade over the big sandbox that I made. But then I realized, wait a second, I just cemented in 4x4 posts. I can turn this into a fort. So I get big sandbox. I put posts around it. Well, I realized that if I cross-beam the posts, then I will have enough room up top for an actual platform with guardrails. Yeah, we cemented them in and everything. So they're going to get a tree house on a property that has no mature trees. Ones you can build on. It was barren former pasture land when we moved in. Everything on there my wife planted. 5 pi over 4, what quadrant win? So if the angle itself is 5 pi over 4, then its reference angle is pi over 4. Negative 240. 2. That is entirely not to scale. Means, what's my reference angle? 60. Okay, formed with the x-axis. 390. Right, because I'm going to go all the way around the block and then another 30. Okay. So here's where the magic starts happening. If that's a triangle, and that's 30 degrees, don't I know my ratios for 30, 60, 90 triangles? So if I know the sine of 30, then I also know the sine of 390. Well, wait a second. I can do stuff with that. If I know one, I know them all. It's coming. It's coming. Unit circle and watching the replay of the video later is how I learned last year that I actually happy flap in class. Happy flap. It's sensory overload when you literally engage in sensory stimulus to regulate emotions. Among the neurodivergent circle, yes. All right, what I would like, because we have problems with radians, you guessed it, I want you to find those three. Because we need practice with radians. Yes. Sketch the angle, find its reference angle. Because you were absent and I haven't updated it yet.
But it was like permanent.
No, Rudy. Rudy, you don't. I already have it on here.
Let's get them all.
No, I usually sit back down over here at the end of class and I poke the thing to end the stream, and then I update attendance and say, yes, Rudy's here.
Rudy. I am.
So is that okay? So this is where I get confused. So then you this one and you just make.
I don't know if I did 12 right.
Oh, okay, got it.
Right?
So then, okay.
I don't know why I did that. I don't know.
But yeah, it just happened.
By the way, I remember you said you were gonna last night.
Yeah.
You just never did, but you ended up texting me. I was like, oh, Andy forgot.
I understand this very well.
I was like, oh, fine.
I'm
I understand this better than the adjacent. I understand this better. Oh, like with the reference stuff?
really?
Like the dimensional analysis.
Negative 3 pi over 4, what quadrant we in? So if that's at negative 3 pi over 4, what is its reference angle? Pi over 4. 7 pi over 4. What quadrant? Quadrant 4. We go all the way around 7 quarters, which means pi over 4 is my reference angle.
We should be teaching kids radians instead of degrees.
Remember when I said that this is supposed to be done in geometry?
This is actually pretty easy.
They haven't done it in geometry as long as I've been here.
I don't know why they don't do that.
Negative pi over 3, what quadrant we in? Okay. Okay. So if that's a negative pi over 3, be careful. What is its reference angle? Pi over 3. Because that's still how far from the x-axis it is. It's always formed with the x-axis. That's it. Well, the front row does it to me all the time.
But I'm not them. I like that redhead always
Yeah, she was fun though. And then she came back a couple years later, but she wasn't a redhead anymore. She dyed her whole hair blue. And it really, really weirded me out because that's like the red gnomes going over to the blue gnome side of the fence. So.
What the heck is Novio and Julia? It's a love story. It's like Novio. I've never seen I've never watched it either.
All right. Ready? Everyone, if you would, close those. Notes off to the side. Find a blank corner of a piece of paper. Rip it out of a notebook. I don't care.
What are we doing? I'm scared.
We're drawing gnomes.
Oh, okay, actually. He just wants us to stop.
There's Gnomeo. And there's Juliet.
I saw it right
Fill in. No. You don't get to use anything. You get a piece of paper.
Oh, we have to close our book?
No notes. Oh, yeah, that's fine. No notes. You get a piece of paper. Fill it in. Oh, yeah, if you want to argue with each other, that's fine. But you need to be able to do this without just looking it up. Again, if you know this, if you know Gnomeo and Juliet over there, red and blue triangle, you can create the entire unit circle.
Yeah, I'm pretty sure we can figure this out.
Okay? If you know these two triangles, you know the entire unit circle.
Okay, let's do the 45 triangle first.
Which is why when you go to trig, Mr. Spear will not let you have the unit circle. He will not let you have this chart because it's the same thing on repeat.
Wait, let's check this.
You can always do Pythagorean to find them.
Yes. 3 squared of 3 squared is 3. 1 plus. It's this, right? Okay.
Yeah.
So it's literally the same thing that we did before?
Yeah.
Okay. That's cool. I'm just gonna try my little table. Items on the line. Crap.
Cosine is adjacent over to
Lots of units in this chapter. How we don't mention radians.
That might have been the day you were out. If there's no degrees, it is assumed to be radians.
I know, it's just
Yeah.
teasing me out.
Well, the legs are going to be the same, aren't they?
Yeah, because it's
So call both the legs 1, do Pythagorean to find your hypotenuse. Now get them.
Okay. Are those like the same? Is that what it?
You swapped the first 2.
Oh, okay.
Remember, if I split pi into 6 units, they're smaller than pi into 3 units.
Okay, 60.
Oh, yeah.
Is that right?
You're going ahead of the pack.
No, I'm still on pi over 6.
Oh.
How are you? Wait,
It's just
Andy.
square root of 3.
Andy, just.
Attaboy.
Oh, let's go. I was like, whoa.
Oh, almost. That one.
I'm so angry about that.
Well, I think pi over 4 would be the 45, 46.
Okay, it's the 30th.
Do you know how to convert radians to degrees?
Wait, do we have to do these radians? Wait, no. So,
The ratio of the side lengths doesn't change.
Yeah, we just gotta work on it. These are gonna be insane.
Okay. So, math.
Come on, Meow.
I know. We just have to.
cosecant is
I don't know. You just said it's not. It's just it's not.
Is it like this?
I don't know. I'm just.
Whether the angle's in radians or degrees doesn't matter. The trig value ratio is still going to be the same.
okay.
Wait. So, opposite over
Square root of 3.
Oh, that's not.
And then cosecant is just.
Yes, it's gonna be square root of 2 over 2.
Oh, we're that.
Okay, so.
Yes.
It's
It's
like,
not just
Oh,
right.
no.
There you go.
Because opposite over.
They're literally going to be tangent flopped.
Wait. No, 1 over
1 over
square
square
root
root
2.
2.
And then you multiply it by square root of 2.
Oh my gosh.
Yes.
Oh,
Yeah, you should. Square root of 2 over 2 is it's the same thing.
Score? Wait.
I messed up the 45.
No, the 45 is correct.
This is just square root.
Yeah, you're good. Pretty sure.
Stop.
Great work, everyone.
Well, I'm going cross-eyed between those 2. That's why. I kind of did the revengeful wakefulness thing last night, so I can't control anything else in my life, so I'm going to stay up way later than I should. And then let's wake up at 4.
How long does it take you to fill this out?
Argon.
It's only like, I want to like time it like the Rubik's Cube. Can we time you?
All right.
Wait, I'll say.
Wait, I already know something.
You gotta tell you when to start.
Ah.
These are Go. You got a time to beat.
Sure, that's right. 6 6 7.
This time crazy.
Well, because like
What's the fact that he knows the chart?
Sine and cosine is equated. Oh yeah, pause.
26, 29.
Woo!
That's
really close. It's tomorrow. I knew I had time.
we're gonna drill this.
So-
This a couple times.
Y'all remember the old school multiplication, like time attack kind of thing?
Dude, I was always so bad at that. I got able to do all this. I don't know why that was a
And my mom, I was
reading.
I was like, wait a second.
Really?
In
What do I do for?
Undo thing.
Yeah. I mean, it should be like something that says. What is
Okay. If you know this, first of all, y'all gonna get really mad at me because they're right there. Okay. So, if I know that chart, can we lock it back in? If I know my special right triangles, if I know my special right triangle ratios, then I want you to think about on a coordinate plane. Remind me again, sine is what? How about coordinate rules? Yes, so opposite over hypotenuse is what over what? Y over R. So in here, sine of theta, if it's going to be y over r, is it going to be positive or negative in that quadrant? Maybe we need to go back to, in quadrant 1, I have positive, positive. In quadrant 2, what are my coordinates?
negative positive?
If I go to quadrant 3, if I go to quadrant 4. So if sine is going to be y over r, it's going to be a positive over a positive. So what about sine in each of the other ones? Back here, my y's are still positive, so positive over positive. Back here, my y's are negative. Radius is always positive. We're getting there. That's on Thursday. And negative, right? What about cosine? Cosine is x over r. So think about those coordinates. X over r. All of my x's are positive on this side, but they're negative on this side. Right? If I know that tangent is y over x, well, that means I'm going to have positive over positive, positive over negative. Negative over negative is a positive. Negative over positive. Okay? which means if I know that the tangent of pi over 3 is what? Tangent of pi over 3 is what? Like just regular pi over 3. Square root of 3. Then if I have an angle such that its reference angle is pi over 3, I can say the tangent of 2 pi over 3, since its reference angle is pi over 3, I know the answer is going to be square root of 3, but it's going to be negative. I don't need to find the tangent of 2 pi over 3. I need to find the tangent of its reference angle. Because if I only know that chart, then I can just make every one of those numbers positive or negative, depending on where my reference angle is. You don't need your calculator for any of this. How many of you saw it already?
That's fine.
I heard a couple of you like, wait, is that right there? Yeah. Okay.
I actually did see that.
Okay. So here's what I do. I combine this chart and that chart, and now I can find all of this without needing to find the trig value of something outside of quadrant 1. Cosine of 120. What is its reference angle? No. 60. How far from the x-axis?
The x-axis would be 180.
180 minus 120 is 60. So I find the cosine of 60, which is?
Yeah, I think that.
I think that is a brownie point. I definitely.
It's a half?
No, I think
All right.
it's a full brownie point.
I think we should vote on it.
I think it should be a class.
All right. What is the cosine of 60? For real? 1/2. All I need to think is, in quadrant 2, is cosine positive or negative? Cosine is negative in this quadrant. So all I do is tack a negative on there. That's it. Now, if you don't want to know that particular chart, there is an old acronym for it. The acronym, what's positive in quadrant 1? All of them. What's positive in quadrant 2? What's positive in quadrant 3? Quadrant 4? All students take calculus. Or if you're my group from 3 years ago, all students tote crack. No, this isn't Gillette. Okay? So, but it's, where was it? It was up there somewhere. Or is it one of my ones that fell down? Oh no, there it is. Wizard staff. Right there.
Wait, you have a wizard staff?
Yeah, I do. I'm still looking for the right crystal for it, but right there. Okay. That place weirds me out.
Wait, so why is it
Because all of them are positive. Okay. So try that again. 7 pi over 6. Lock it back in. What is the reference angle of 7 pi over 6? How far away from pi is it?
1/6?
Pi over 6. So, what's the tangent of pi over 6 that we should just know?
Oh, wait. 30.
No, that's it in degrees. What is the tangent of the angle? So if that's square root of 3 over 3, what quadrant is 7 pi over 6 in? All students take calculus. Tangent is positive in quadrant 3, so this remains positive.
I like that.
Now you don't have to do it this way. Could I just 7 pi over 6 right there? So this is pi over 6. So that's 1, or that's square root of 3, 1, 2. Which of those is going to be negative? If I'm in quadrant 3, it's like 7 people not listening, so I got no problem just saying, here's the notes. The examples are worked out in the book already. Have fun. That's what PreCalc was before I took it over. It was literally, here's the book, read the section, do these 40 problems, we'll go through them tomorrow. That was the entirety of the class. I try to give you as many examples as possible so that you don't have to struggle. If I'm in quadrant 3, which of those 3 measures is going to be positive or negative? Right? This is at negative square root of 3, negative 1. Could I now use my ratio of tangent and say negative 1 over negative square root of 3? And then rationalize it. You don't have to use, I know this chart and asked. Okay, you don't have to use this, what quadrant are they positive or negative in, and those ratios. You can just reinvent the wheel every time. Sometimes you're going to run across an angle that stumps you, and you have to reinvent the wheel. What quadrant is 15 pi over 4 in? It is in 4. The first thing you recognize is that 15 pi over 4 is more than a full revolution. So I'll take away 2 pi. So it's something more familiar. And then, if 7 pi over 4 has a reference angle of what? Well, maybe I don't know what the cosecant of pi over 4 is off the top of my head. But cosecant is the reciprocal of what? Sine. If I know that the sine of pi over 4 is square root of 2 over 2, then its reciprocal is just square root of 2. You see how you don't have to know the entire chart. You just have to know half of it. And then I'm in quadrant 4. All students take calculus. How do I know if cosecant is positive or negative? It's the reciprocal of sine. Sine is negative in that quadrant, so cosecant will also be negative in that quadrant. Now again, I don't have to do it that way. I could just sketch this out, quarters, quarters. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There. It's right. Oh, I know that one. That's pi over 4. 1, 1, square root of 2. Wait, that guy's got to be negative. Cosecant. Square root of 2 over negative 1. Okay? You can reinvent the wheel if reinventing the wheel is faster for you than thinking through that. Two philosophies, both work. You ever watch MMA fights? You got the guy who's like, I'm just going to knock that out of the way, knock that out of the way. I'm going to play defense, let you get tired, and then just, you're gone. Versus the guy who's just, offense! Okay? Like, they're two different philosophies. They both have the same end goal. Make dude on floor. Okay? So, I don't care which which method you use. I don't care who you fight, just don't do it in my room. Okay?
I heard there's a fight in Mrs. Watts.
I hope not, because she's one of the sweetest people in the world.
She said it's like the first time she's ever like yelled at people.
I believe that.
Hello, Miss Watts.
Yeah, like Robert.
Why would they do that?
Yeah. Why? Because I want things.
Can you please do this?
Yes. Yeah. She said, Mr. Sister, we know it. Me and him are buds.
Can I just write this to show I got it?
Hey, if you can think it through, go for it. However, that's not the answer. It's just the angle. Find the value of the trig ratio.
That's negative.
What's negative square root 3?
Yeah.
Sine of pi over 6. Pi over 6.
It's just hard to do.
Sine.
No, it's 6 over 6.
Oh, wait, that makes sense. Wait. No, it's not. 5 pi over 5. What are 5 thirds?
So it's in here.
No, it's not 3. It's in 4. It's in 4. Yeah. No, it's still negative. It's still negative. It's fine. Okay, 5, 6. That's important. Sine is positive. Why did they have to go into degrees?
What?
This is you just converted blasphemy.
Wait, what is it?
What is it? Watching degrees. You know, it's negative.
Yeah.
Yeah, that one is very good.
Oh.
My bad.
Okay, what's the
Just
angle?
convert it to read.
45 degrees.
Secant.
Oh, just pi over
Yeah,
4.
over 1 times.
Pi over 4.
The more you do this, the more you're willing to actually think through it instead of just look things up. You start seeing the angles as their equivalent. I don't see 135. I simultaneously see 135 and 3 pi over 4. Kind of like someone who's genuinely bilingual can see words or hear words, and they can see it and hear it in both languages as an equivalent. Okay. Like if you are truly bilingual. Now sometimes you got to stop and think, just like if I saw 21 pi over 4, that's not going to be an easy switch for me.
Yes. Wait, hold on. Andy. Be quiet. He's trying to eat.
He has been for the last 2 minutes. First, get your reference angle. If you know what the tangent of pi over 3 is, which is, if you know what the sine of pi over 6 is, I might not know the secant of pi over 4 off the top of my head, but I do know the cosine of pi over 4 is square root of 2 over 2, so I can cut that into square root of 2, reciprocal. Then you just ask, what quadrant is it in? If 5 pi over 3 is in quadrant 4, this is negative. If 5 pi over 6 is in quadrant 2, this is positive. If negative 135 is in quadrant 3, then this is negative. If you're good, you can go straight to yellow. If you're good. I didn't have to write too much before that. So a little bit of that for your work shown, perfectly fine. Okay? It allows you to just memorize your right triangles, that little cheater quadrant thing, and you're good to go. Yeah, I'm done.